Hi you all, good morning. How are you? I hope all of you are fine. So today we want to continue our lesson with the next part in chapter 2, which is 7.4 electromotive force and internal resistance. So you can refer to your notes. This one is on page 50, right? So I hope you have already go through the notes so that you can understand better. Okay. Okay, for this topic, EMF E and internal resistance. So I think you have, if you have a battery, you can just look at the label of the battery. For this one is 1.5 volt. So you can see the label there, 1.5 volt. Okay. So what does the label means? Okay. The label of the battery means the total voltage that can be supplied by the battery. So what is voltage or potential difference? I hope you still remember the definition of potential difference or voltage. V equals E over Q. Okay. E is electrical energy consumed or work done to transfer 1 coulomb of charge between 2 points in an electrical circuit. So that one is potential difference or voltage. When we talk about EMF E, is the total voltage for the whole circuit that's supplied by the battery. So meaning from the positive terminal to the negative terminal, the total energy consumed per unit charge in the whole circuit, we call it EMF. Okay, so look at this circuit. For this circuit, we have a battery. This is positive terminal, this is negative terminal. Let's say we let the switch open. So when the switch open, so this one we call it open circuit. Why we call it open circuit? So as you can see, when the switch is open, the circuit is broken here, meaning the current cannot flow. You still remember current will flow from high potential, positive, to negative. So the circuit is broken. The voltmeter does not allow current to flow, high resistance. So meaning for this circuit, there's no current flow, meaning I equals to 0. So once we have open circuit or the switch is open, meaning no current flow in the circuit. Can the voltmeter measure something? Can. Let's say this voltmeter we connect here, point A and point B. Meaning the voltmeter will measure potential difference between positive terminal and negative terminal. As you can see, the positive is connected to A, the negative is connected to B. So the voltmeter will measure potential difference across the terminal of the battery. So when I equals to 0, the reading of voltmeter V is equals to EMF E. Because we have discussed before, electromotive force is the total voltage supplied for the whole circuit, or electrical energy that used to transfer 1 unit of charge between terminals of the battery. So if the voltmeter here measure the voltage supplied by the terminal of the batteries, meaning the reading of the voltmeter now is EMF. So in order to determine what is EMF of the battery, so we let the switch open, or we have the open circuit. So we get the reading of the voltmeter equals to EMF. Okay, so that is the first situation. Okay, now if we let the switch close, what happened? Close the switch. Okay, so we call it closed circuit. For closed circuit, meaning of course there will be current flow. The circuit is complete. The circuit is complete, so there is a current flow. Okay. The current will flow from positive to negative I. Okay. Okay, the current will flow. Once the current flow pass through the bulb, let's say the resistance of the bulb is R, meaning there will be some of the voltage used to overcome resistance of the bulb. So meaning V equals IR. Okay, V equals IR. Okay, so the voltage coming from the supplied by the battery. Okay, now once we turn on the switch, the reading of the voltmeter will drop. Okay, why? Okay, now for the battery, it has its own resistance. Very small resistance due to electrodes or electrolyte of the battery. For this battery, it has electrodes inside, so there must be resistance. Okay, so this is internal resistance. The internal resistance is inside the battery. Once the current flow through the battery also at the same time, there will be work done to overcome the internal resistance. Okay, just now we have V equals IR is work done to overcome resistance of the bulb. Now we have one more. To overcome the internal resistance, that is I times small r. Okay, so meaning we will get this right here. So meaning the total energy per unit charge supplied by the battery, which is EMF, some will use to overcome resistance of the bulb, that is V. Some will use to overcome the internal resistance of the battery. Okay, so from here we get the reading of the voltmeter V, which is connect between A and B, actually equals to reading of the voltmeter across the bulb, because the bulb is also connected to the same point AB. So when the switch is closed, the reading of voltmeter here is equals to the reading of the voltmeter here. If you have another voltmeter here, it should be the same because they are connected to the same point. Okay, so what we get from here, V equals E minus I small r. Meaning, when there is current flow, there will be voltage loss that we call I times small r. So this one will cause the reading of voltmeter become smaller than EMF. Or we can say the reading of the voltmeter decrease, okay, when current flow. So this is how we get the equation. This equation, okay, that we can use to solve many calculation problem. And the V here is equals to IR, means for the bulb or any resistor in the external circuit. Okay, so this one is about concept of EMF and R. So you need to know the definition of electromotive force, means work done to transfer 1 coulomb of charge to the whole circuit. Okay, and then the internal resistance is resistance of the battery due to electrodes and electrolyte. Alright.